Let's take a look at this, right? Explain why the intensity of light is 16 I naught. Well, there's no reason you would get this, okay? What you have to understand is that the amplitude in the center, right there, okay? The amplitude, okay, is going to be, because there's 4 slits, it's going to be 4 times as high, okay? Then if you look in subtopic 4.3, you'll see this thing that I really haven't talked about, but that I'm going to, talk about here. Okay, and that is that the intensity is proportional to the amplitude squared. And the reason for that is, if you recall, in simple harmonic motion, the total energy is 1/2 m omega squared x naught squared, right? So it's proportional to the frequency, right? It's also proportional to the amplitude squared, right? And that's where this comes from, okay? So if you think about this, right, if the amplitude is 4 times as high, and that's because we have the superposition at the center at the screen, right, of 4 different slits, right? So they're all going to be in constructive interference. Remember, the principle of superposition states that when waves overlap, the resulting displacement is the vector sum. Okay, so the vector sum of 4 is 4. 4 different slits would be 4 times, right? Okay, so if it's squared, well, 4 squared. There we go. All right, so make that argument. All right, the width of each slit is 1 micrometer. So they're talking about this distance here. Estimate the wavelength of light. Okay, so what you're going to do is you're going to go, okay, sine of theta, which by the way is approximately equal to, say, theta, is also equal to the lambda divided by the width of this slit, right? Okay, so this is our B. And then the diffraction pattern has a minimum that's about here. Would you say it is? I don't know. Okay, so what you want to do is read this graph. Notice that it's in radians, okay, and that you need to be in radians, okay, and then you're set. Okay, so read that graph, put that in there, make sure you are in radians, and you will get a wavelength of light that's somewhere between 400 and 500 nanometers. I'm just going to say, okay. So that's that business there, okay. And we've been doing this. This is the single slit diffraction pattern type thing, right? Okay. And then the second part says determine the separation of 2 consecutive slits. Okay, so they want us to find what this is. Okay. Now specifically, that is the D in n lambda equals d sine theta, right? Okay, so really what we want to do is we want to look, we could look at this first one here, right? This looks solidly, you want to read this guy here, like it's right in the middle there. Okay, even better, this one is 2 of those, right? They're making them fall right on the line, right? Okay, isn't this 0.25 radians? Right? So you could take 0.25 divided by half, and you would get the what that angle is, right? Feed that into there. So read the angle, feed that into there. Lambda, you just figured out from before, and then n. Well, if you're going to this guy, n is 1. If you're going to this guy, n is 2. Okay. And it probably is better to go to the outer one or something like that, but it doesn't matter because they fall right on grid lines. So they're pretty cool. So read the graph. This is your answer from here, that number that's between 400 nanometers and 500 nanometers, or 4 times 10 to the minus 7th and 5 times 10 to the minus 7th. Okay. And then you can figure out this D, and that D is on the order of micrometers. It's between 3 and 4 times 10 to the minus 6th meters. All right.